Hello, dear children. Welcome to today's class. Let us continue with the sixth chapter, indices. In the previous video, you have seen multiplication of indices with same base. Today, we are going to see division of indices with same base. So, children, get ready with your textbook and notebook. Now, division of indices with same base. Let us see some examples. Example number 1. 6 raised to 4 divided by 6 raised to 2. Here if you look at both the index numbers, the base is same, that is 6. Now here it is given using division sign. We can write the same in numerator denominator form. So it is written as 6 raised to 4 upon 6 raised to 2. You know 6 raised to 4 is 6 multiplied 4 times and 6 square is 6 multiplied 2 times. Now, we can cancel 6 from numerator and denominator. So, here 2 6 will get cancelled. Then only 2 6 will be left in the numerator. That is 6 multiplied by 6. We know that 6 multiplied by 6 is 6 square. Now, if you look at the question and the answer, here 6 raised to 4 divided by 6 raised to 2 is 6 raised to 2. Now, what relation do you see, children, here in the index number? Here 4 minus 2 is 2. That is in division. If the base is same, we can subtract the index number or we can subtract the exponent. That is 6 raised to 4 divided by 6 raised to 2 is equal to 6 raised to 4 minus 2, that is 6 square. Now, let us see another example. Here negative 2 raised to 5 divided by negative 2 raised to 3. Again, we will write it in numerator denominator form. Here negative 2 raised to 5 upon negative 2 raised to 3. Here negative 2 raised to 5 is written as negative 2 multiplied 5 times. Negative 2 raised to 3 is written as negative 2 multiplied 3 times. Now let us do the cancellation. Here this negative 2 will get cancelled with this negative 2. In this way, here 3 negative 2's will get cancelled from numerator and the denominator. Now how many negative 2's are left? 2 negative 2's are left. That is negative 2 multiplied by negative 2. It means negative 2 square. Now look at the overall example here. Negative 2 raised to 5 divided by negative 2 raised to 3 is negative 2 raised to 5 minus 3 is 2. Now from these two examples, we conclude that if A is a non-zero rational number, that is base. Here the base is rational number, here it is 6, here it is negative 2. A is a non-zero rational number. What do we mean by non-zero, children? Non-zero, it means any number except 0. M and N are positive integers. That is, here the index should be positive integer and M greater than N. That is, index of the numerator is greater than index of the denominator. Then A raised to M upon A raised to N is equal to A raised to M minus N. In these two examples we have seen the base is a non-zero rational number. Here the index are positive integers and index of the numerator is greater than index of the denominator. Then A raised to M upon A raised to N is equal to A raised to M minus N. Now let us see the meaning of A raised to 0. Now here what is the meaning of A raised to 0? That is, if 0 is in the index of any rational number. Now here the condition is that the base should not be 0. Now let us see, if base is not 0, we have seen A raised to M upon A raised to M will be A raised to M minus M. Here a raised to m upon a raised to m. Here both the numerator and denominator are same. We have seen when the same number is divided by the same number, then the answer is always 1. Also, according to the rule that we have seen, now a raised to m upon a raised to m. Here the base is same, we can subtract the index. That is a raised to m minus m, it is equal to a raised to 0. Now in these two cases, we have seen a raised to m upon a raised to m is 1 in first case, whereas in next case, a raised to m upon a raised to m is a raised to 0. From these two we conclude that a raised to 0 is equal to 1. So, if 0 is in the index of any rational number, the value of that number is always 1. Now, let us see the meaning of a raised to negative m. Here a raised to negative m, we know that 1 multiplied by any number is the number itself. So here we can write a raised to negative m equal to a raised to negative m multiplied by 1. Just now we have seen 1 can be written as any number divided by itself. So here we are taking 1 as a raised to m upon a raised to m. Now children, if you look at this step, here a raised to negative m multiplied by a raised to m. These two numbers are in numerator. Here the bases are same. So we can add the index. Therefore, a raised to negative m plus m we can write in the numerator and a raised to m will remain in the denominator. Now negative m plus m is 0. So we will get a raised to 0 in the numerator and a raised to m will be left in the denominator. Just now we have seen a raised to 0 is 1. Just now we have found the value of a raised to 0. That is any number raised to 0 is always 1. So we can equate here 1. A raised to 0 is 1 and a raised to m will remain as it is. Now look at the initial step and the final step. A raised to negative m is equal to 1 upon a raised to m. That is converting negative index into positive one. We have to take the number in the denominator. When you convert the negative index into positive one, the number goes into the denominator from the numerator. Here and the negative sign will be disappeared. A raised to negative m is equal to 1 upon a raised to m. Now let us see multiplicative inverse. A raised to negative m is equal to 1 upon a raised to m. Just now we have seen converting negative index into positive one. The same example has been taken here. A raised to negative m equal to 1 upon a raised to m. If you take m as 1, then you will get a raised to negative 1 equal to 1 upon a. Here if we take 1 in the index, that is if we take 1 as the value of m, we will get a raised to negative 1 equal to 1 upon a. Now we have also seen a into 1 upon a is 1. That earlier you have studied this. A multiplied by 1 upon a is 1. How it comes? A and a will get cancelled from the numerator. Only 1 is left. Hence the answer of a into 1 upon a is 1. Here 1 upon a is multiplicative inverse of a. We have seen 1 upon a is a raised to negative 1. So we will write a raised to negative 1 in place of 1 upon a. So we get here a multiplied by a raised to negative 1 is 1. Hence a raised to negative 1 is multiplicative inverse of a. When we say one number is multiplicative inverse of other, when the product of two numbers is 1. When the product of two numbers is 1, we say that one number is multiplicative inverse of other and the other is multiplicative inverse of the first. Hence, in this step, we conclude that a raised to negative 1 is multiplicative inverse of a. Thus, the multiplicative inverse of 5 upon 3 is 3 upon 5. That we have already seen. Now, In the previous classes, we have learnt when we take the reciprocal, we call it as the multiplicative inverse. Now, how we will write it using index or using exponent? 5 upon 3 raised to negative 1 is 3 upon 5. Here, when we put the index as negative 1, we write the multiplicative inverse of 5 upon 3. Multiplicative inverse of 5 upon 3 is written as 5 upon 3 raised to negative 1. It is 3 upon 5.